All right, so we are officially in week 3. Okay, and last week, week 2, we talked about selection, and yeah, you got the benefit of having a lecture on Thursday, and I had to cram last week and this week's lecture all into one for the Monday class, which is okay. You don't care. So, this week we're going to practice with selection, and we're going to be finding smallest, largest, sum, and average. That's not in here yet. Okay. So, the one thing that I'm going to tell you new is random numbers, and I'm also going to tell you something new about the different number systems, binary number system, hexadecimal number system, and how you convert between the different ones to our number system, which is the decimal. So the first thing is how to make a random number. Okay, so this is 13, 14, oops, 13, 14. Okay, so don't forget, these comments on top of every program are worth plenty of your grades. Don't forget to include them. You also need to have some kind of a description. All right, so what I'm going to do is I'm going to use what I wrote for the Monday class, so I don't have to type it up all over again. And this is how to make a random number. Okay, so to make a random number in C++ is a little bit more involved than Python or Java, if you've taken those, and it involves using the system time to generate a random list of numbers. Okay, so this piece of code right here gets the system time, right? So the system time is just like some huge number, like a million something, and it just keeps changing and changing and changing every second. So every time I run my program, the system time will change, and this right here, time no, allows me to get the system time. So I'm going to get the system time. I'm going to put it into a variable called ASCII, and then I'm going to put that into srand. Srand here. So what srand does is generates a random list of numbers. Okay. So if I put a number like say 0 here, okay. If I have an srand 0, then srand will generate the same list of numbers every time. Okay, they're going to be kind of like in random order. They're not going to be in sequential. They're not going to be ascending or descending order. It's going to be like a bunch of random numbers, but it's always the same list of random numbers. Okay, so the way I'm going to change that random list of numbers, and by random list of numbers will be things like like something like this, and then something else, and then something else, right? So there's just a whole lot of these, a big list of random numbers, okay? And then what we're going to do is we're going to use this modulus operator to kind of reduce this big number into a smaller list of numbers, okay? So do you remember this percent sign thing? Do you remember how that works? If you don't, okay, good. So if you don't remember, let's have a quick review for this. So let's say if I have, let me take this off. I'm going to take this off for a second. Okay, so that I can explain to you how the modulus works. So remember, we have the different operators, right? The operators. We have the plus, you have the minus, you have the multiplication, you have the division, you have the assignment operator, and there's also this modulus. All right, so this here is also known as, this is the modulus or modulo or the remainder. Different people call it different things. I tend to call it either the modulus or the remainder. Okay? And don't confuse this one with the division, even though it kind of looks like you're dividing something, it is not a division. Okay, so the way to, if I have something like this, C out, I have 5 divided by 3, all right, and del. Okay, 5 divided by 3 equals this. Okay, and if I run this thing, I get a 1. Okay, so why is it 1? Well, it's supposed to be 1 point something, but because this is C++, it thinks that because you're having one integer divided by another integer, then the result must be an integer. So if you wanted to see the decimal, you would do 5.0 divided by 3.0. So 5.0 divided by 3.0. All right, and let me run this thing again. And then you see that now it actually gives you the correct number, which is 1.66667. Right? So that's what happens when you divide numbers. Okay? Now let's have a look at what happens when I do the modulus operator. All right? C out 5 modulus 3 is equal to 5 modulus 3 and del. Okay? Run it again. Now you get a 2, okay? So it's not a 1, it's not a 1.667, it's a 2. You might think, well, hold on, it's kind of rounding up this number. That's not what's happening, okay? So let's examine this modulus operator, how it works. Okay, so the question that I'm asking is, how many times does 3 fit into 5? How many times? 1 time, right? 1. So what I do is I say, all right, 5 minus 1 times 3 is equal to 5 minus 3, which is 2. Yes? That's how the remainder operator works. Okay, let's do a few more. So I'm going to grab this thing, I'm going to copy it. I'm going to do a 6. Okay? And the same question, how many times does 3 fit into 6 now? Twice, right? So it goes the same way. You have 6 minus 2 times 3 is equal to 6 minus 6, which is 0. Okay, so if I run this again, I should see that there it is, that's the 0. Okay, let's do a few more. So I did the 5. So this one was a 1. Sorry, not 1. This was a 2. I'll just leave it there. Okay, so next one, I'm going to grab this, copy it. Now we're going to do 7 modulus 3. Okay, 7 modulus 3. Same question. How many times does 3 fit into 7? Still twice, okay? So then I do 7 minus 2 times 3 is equal to 7 minus 6, which is a 1. Right? So if I'll run this thing now, there's your 1. Okay? And so on and so on and so on. So let me just do one more. Let's do the 8. All right? 8 modulus 3. Alright, same question. How many times does 3 fit into 8? Still 2. Okay, 2. So we do 8 minus 2 times 3 is equal to 8 minus 6, which is 2. Right? So if I run this thing now, it's a 2. If I keep going, you're going to notice that these numbers here are always going to be 210, 210, 210, or 012, 012, 012. So in other words, if I have any number modulus 3 is going to be equal to either 0, 1, or 2. That's it. Okay? So it's basically a way for me to grab a really big number and say, okay, if I get a really big number and I do modulus 3 on that thing, then I'm going to get a number between 0, 1, and 2. So it's a way for me to reduce a really big random number to a smaller group of random numbers. Okay? So let's say, and that's the purpose of this rand. So let me show you. Cout, let me change this to iSeed. Okay? So if I do rand, just like this, and L, I'm going to show you rand equals rand, right? Okay? So rand is just going to be one of these random numbers in here. I don't know exactly what. It'll just be some big number. Okay? So if I run it, let's see what rand is equal to. Whoa, even bigger than I expected. Right? Several million. Okay, if I run this again, it's a different random number. Okay, I run it again, different random number. I run it again, different random number. Okay? So, what I'm going to do is, I'm going to get this any big random number, and let's say I want to make, so let's suppose this thing makes me some big number. This is some big random number like this, right? Okay, so then if I go and I grab this thing and I say, all right, cout rand modulus 3, what do we say that this is going to be? Rand modulus 3 and L. Can you predict what the result of this one is going to be? Excellent. So this is going to be some number between 0 to 2. Okay? So if I go and I run it, that's a 0. Run it again, 2. Run it again, 1. Run it again, 2. Run it again, 0. Alright, so there you go. That's how you make a random number between 0 and 2. Okay? So far so good? Okay. So now let's say I want to make a random number between 0 to 10. What do? Let me copy this thing here so I don't have to write it. Alright? What do I change this here to? I want to go from 0 to 10. $11. Good. So if I change this to 11, alright, I should get a random number between 0 to 10. Right? If I run the program a bunch of times. Right? So it's a 6, 2, 1, 0. There you go. We got a 10. Okay? A lot of times it will just, you run the program a bunch of times and it will just keep making the same random number just to piss you off. Don't worry about it. It's supposed to be random. So that's one. Now let's try some other ones. Let's say I want to make a random number between 0 and 27. What do I change this to now? 28. Okay. All right. And maybe I should have an equal sign. Okay. Run again. All right. All right. So yeah, 28. It shows some number between 0 to 27. I'm not going to run the program a bunch of times so we can see if it shows all of them. Okay. Later on, I'll show you how you can make the program repeat a bunch of times so you can see these things, but not now. Okay. So if I do this, that's what it shows. Now, let's say I want to make a random number. Last one. I want to make a random number between 0 to 5. What do? 6. Okay. Yeah, so that's good. I'm not going to run it, so because you already know. Okay. Now let's turn it up a little bit. Now I want to make a random number between 10 to 15. Now how do I do this? You said 16, right? All right, that's a good guess. If I said 16, then what is it going to do? Then that will make me a random number between 0 to 15. So I can't do 16.
Can the two numbers be different? The two 16s? Like, if one on the left be to like 10 and the one on the right be to like 15, does it between them?
You're on the right track. Okay, so the one on the left, we're going to do this. We're going to say, all right, we're going to have a 10 here plus this number. All right? So now, we already said that this thing here, this is going to make me a random number between 0 to 5, correct? Okay, well if I add 10 to that thing, now I get a random number between 10 to 15. Make sense? Okay? Got it? Sure?
Yes.
Okay. You got it too? Alright. So let's go on to the next one. I want to make a random number between 20 to 25. Now what I do? 20, I heard a 20, so yeah, I'm going to change this to 20. And this one stays as a modulus 6, because this is going to make me a random number between 0 to 5. Add 20 to this thing, now I'm going to get a random number between 20 to 25. Yes? Okay. Now let's do some more. Let's say I want to make a random number between 50 and 60. Now what?
Plus 50 and 10.
50 plus what?
Plus 50 and 10.
11. 11.
Sorry.
All right. So this makes me a random number of 10 between 0 to 10. Add 50 to that. Now I have a random number between 50 to 60. Okay? And if it seems confusing, we can reduce this thing to basically this format. I can say, all right, int min is equal to, let's say, 50 here. All right? I'm going to have an int max is equal to 60. Right? And I'm going to represent this thing in terms of min and max. That way you don't have to do the math in your head every time. Okay? So what I'm going to do is alright, this is a random number between 50 and 60. Copy. Alright? What I'm going to do is I'm going to say this here is which variable? Min. Okay? And how am I going to express this number here? What is 11 using these two numbers? It's actually max minus min. That's a 10, right? Add 1 to it. That's your 11. Make sense? So the min is the 50. This number here is max minus min plus 1, which is 60 minus 50 plus 1 is 11. Yes? Okay. So if I change this thing to min plus rand max minus min plus 1. Okay, so this is how we make a random number in C++. Okay, it's a little bit more complicated than other languages, but whatever. We can do it. So, any questions on this stuff? Make sense? Okay. So this is how we make random numbers, and now you know about the modulus operator, which is, it basically allows you to get a big number and shrink it down to a smaller group of numbers. Okay? All right, so this is the random number business. Now let's see what else. Some of the things that I covered last time. Let me grab this stuff here and copy this in there. So this is like a little bit of review of last time. All right, we have covered already the relational operators. What are the relational operators? Ways to check to see if something is equal, greater than or equal, less than or equal, not equal, less than, greater than. Right? Okay. And by default, and how does the computer know how to do these things? It's built into the processor. The processor has two pieces in it. One is the control unit, one is the arithmetic logic unit. The purpose of the arithmetic logic unit is to do some logic, right? And arithmetic. So the kind of logic that it does is it can compare two numbers to each other. It can tell you, are they equal? Is one less than the other one? Is the other one greater? Are they not equal? Or less than or equal? So all this stuff, this is just built into the processor architecture itself. And our language, computer language that we're using, most of them, or all the computer languages use these relational operators in one form or another. Okay, so if you did something like this, go with this. All right, so these here are your conditions. I'm gonna copy this, paste it in there. All right, so if I say C out 3 is equal to 4 is something, right? So this is equal to 3 is equal to 4. This, when you're comparing two things to each other, we're calling that a condition or a Boolean condition. It's also known as Boolean algebra. It's an algebra of true and false. Okay, and it is again something that the processor can do on its own. Okay, so that's a condition, checking to see if something's true or false. And I gave you different examples of conditions in here. You can check to see if two numbers are equal to each other. You can check to see if two variables are equal to each other. If they're not equal, if one is greater than or equal than another, if one is less than or equal to another, right? And if I run this thing, you're going to see that C++ actually shows you false as 0 and true as 1, right? So if I go in there and I do, let me grab this one, copy this, all right, paste this. So if I have 3 is not equal to 4, right? Run it again, right? So 3 equals 4 is a 0, 3 is not equal to 4 is a 1, okay? So the default way that C++ shows true is 1, and the default way that C++ shows false is 0. Right? So 1 is true, false is 0. Okay? Now, there's a way for us to change this to something a little bit more meaningful, and that is if we do this line. If I go in there and I do this right here, cout, setf, std, ios, bool alpha, right? That will allow you to change the 0 to false and the 1 to true. So if I run this again now, you're going to see some false and trues in there. Okay, to me that makes a little bit more sense. So this true and false is it's the Boolean data type, right? So I can say something like bool true false or true false is equal to true, right? And then I can have another one, bool false true is equal to false, right? This is your Boolean data type. Boolean data type, okay, which in C++, we already saw 1 is true and 0 is false. Okay, so even though it's called its own data type, just like we have int and float and double and character and string and some other ones, then Boolean is another data type, but it really is just 1 and 0. 1 is true, 0 is false. Okay. And this kind of leads to the binary number system, right? The binary number system has two numbers. You have a 1 and you have a 0. Okay? So what I'm going to do is, at this point, I'm going to go back to the class page and I am going to look at this here, converting between binary and decimal. All right? I'm going to open up this link. All right, and there's this little thing that shows up. So let me give you that little story. Okay, so how the computers see data. Computers can see either on or off, right? Which we choose for our own convenience sake to express as the numbers 0 and 1, right? Actually, 1 is on, 0 is off, 1 is true, 0 is false, right? We could have just as easily picked the other way around, 1 to be false and 0 to be true, but that's what we decided on. Okay? And if we want to do math with just these two numbers, we need to use the binary number system. Okay? And what is the binary number system? Well, I'll show you in a second. But just so you know, bit is the smallest piece of data that a computer can work with. So what is a bit? A bit is either on or off. So there's either electricity flowing through the little piece of circuit and it's on, or it doesn't and it's off, right? When it's on, it's true. When it's off, it's false. Okay? So 0 and 1. If you have 8 bits, that's called a byte. If you have 1,024 bytes, that's a kilobyte. If you have 1,024 kilobytes, that's a megabyte. And they basically go in multiples of 1,024. Okay? It's not exactly multiples of 1,000, but it's 1,024. Okay? So, let me open up this thing here. Let me open up a new one. Okay? So what I'm going to do is, I'm going to do this. So let's say we have decimal, and then we're going to have binary here. Okay? So decimal 0 is, if I have, let's do it this way. So the binary is basically this underscore here. So the binary can be either 0, or if it's a decimal, then that will be a 1. Okay? Now, how would I do this if I have the number 2 in decimal? I can't use it with just 1 bit. So this here, this is 1 bit, right? And what is 1 bit? 1 bit is either 0 or 1. That's it. Okay? If I want to have just the numbers 0 and 1 in decimal, then 1 bit is enough. But if I want to have more than 0 and 1, like for example 2, how am I going to express this thing with binary? I need 2 bits. 2 bits. Right? So let me erase this here. Right? So if I want, this is here is 2 bits. Okay? So let's say I have the number 2. So what is going to be the binary representation of? All right, let me do it one more time. So if I have 2 bits, 0 is going to be 0, 0. Right? That's decimal 0. Decimal 1 is going to be 0, 1. Decimal 2, what do you think that is going to be? 1, 0. Just like in decimal, if you have 9 and you add 1, it goes to 10, right? That's the kind of the same thing. So yeah, I'm adding 1 to this one. So this becomes a 0, this bit becomes a 0, we carry the 1 over, so now it's a 1, 0. Okay? So that's the binary representation of the decimal 2. So how would I do decimal 3 then? 1, 1. Okay? And let's do another one. So I'm going to grab this whole thing here, copy it, paste it. So now I'm going to have 3 bits. Okay? So 3 bits. And it goes the same way. So I'm going to go in there. I'm going to say, all right, this one is going to be my 0. Right? 0, 0, 0, 0. The 1 is going to be 0, 0, 1. My 2 is going to be 0, 1, 0. My 3 is going to be 0, 1, 1. Right? How am I going to do a 4? It's a 1. Where? 1, 0, 0. Right? Then a 5. What is a 5? 1, 0, 1. What is a 6? 1, 1, 0. What is a 7? 1, 1, 1. Right? And that's as big of a decimal as I can represent with 3 bits. Okay? So then if I want to make a number 8. Let's do this too. Paste. Underscore. So now we have 4 bits. It's bits. Okay. And same business. So you have a 0. That's a 0, 0, 0, 0. 1 is your 0, 0, 0, 1. You have a 2, which is 0, 0, 1, 0. You have a 3, which is 0, 0, 1, 1. 4, is 0, 1, 0, 0. 5, 0, 1, 0, 1. 6 is 0, 1, 1, 0. 7, 0, 1, 1, 1. 8, what is the 8? 1, 0, 0, 0. 9, 0, 0, 1. 10, 1, 0, 1, 0, 1, 0. That's there. 11, 1, 0, 1, 1. 12, 1, 1, 0, 0. 13, 1, 1, 0, 1. 14, 1, 1, 1, 0. 15, 1, 1, 1, 1. Okay? So that's the logic of things. Okay? So the way it actually works out is this. So let's say you have, I'm going to go with, so, and remember that 8 bits. So I'm going to have underscore, 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 a little bit of space, underscore, 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 underscore. Let me put a dot in between. Now I'll leave it like this. Okay? So this here is 8 bits, which is equal to 1 byte. Okay? So, the way it works is this. So I'm going to go with this one here. So the first one is a 1 in decimal, right? So this is your decimal. Okay? This here is decimal. Okay? This one here is 2. Right? If you go up in here, remember, if you have this here, that's a 2. If you have this here, that's a 1. Right? When you have this bit here as 1, right? It's a 1. So you have a 1, then you have a 2, then the next one over is going to be a 4, then the next one over is going to be an 8, then what do you think this one's going to be? See how they double? 16, right? You go down, 32, you go down, 64, you go down, 128. Okay? So there's like kind of a, there's kind of a shortcut to figuring out if I went in there, so if I have 8 bits, right? So I have this. If I have underscore, 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 right? So if I have this, if I have a 1, 1, 1, 1, 1, 1, 1, what do you think that is? You got to go and add up all these numbers, right? Okay, but if you noticed, maybe, where is this thing here? Where is this? Right here. See this? When I have 3 bits and they're all 1s, that's this right here. And then the next number over is when I have the 4 bits, and this is a 1. Now it's an 8. So by looking at that, can you tell me what this number is going to be here? It's 1 less than this. So this here is 127 decimal. Make sense? Okay, if I have 1, 0, 0, 0, 0, 0, 0, 0, that's 128, right? So you basically add 1 to these here, you carry over this the 1, then they're all zeros, and then it's a 128 decimal. Okay? The biggest number that we can represent with 8 bits is 256. Okay? It's actually 255. Make sense? Right? Why? Because we have 127 plus 128, that's 255. Yes? All right. So that's the binary number system. And I already showed you that they basically double up, right? Like this. Now let me explain to you why that stuff happens. So let's examine our decimal number system. This is our decimal number system. What is the decimal number system? It's got 10 numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Okay, that's why it's decimal, because it's got 10 digits. Okay, so if I wanted to represent the number 365 in decimal, I could say it as 300 plus 60 plus 5. That's equal to 365. Another way to say this is to say 3 times 100 plus 6 times 10 plus 5 times 1, which is also 365. And yet another way to do this is to say 3 times 10 to the power of 2, right? 10 times 10 is 100, plus 6 times 10 to the power of 1, 6 times 10 is 60, plus 5 times 10 to the 0. Anything to the power of 0 is what? 1. 1, right? Anything to the power of 0 is 1, always. Okay? So, why is the base 10? Because we have 10 digits. Okay? So now you learned a little bit of something about how our number system that we take for granted maybe, and we use every day, how it works. That's how it works. Okay? So the same logic applies when we have binary number system, and that's why it doubles. Okay? In the decimal number system, you have the power 0, then the power of 1, then the power of 2, then if I have another number, you know, if I'm trying to express 1,000, then it will be 10 to the power of 3, right? 10 times 10 times 10, right? 10 times 10 is 100, times 10 is 1,000, right? So the base is 10, and the powers just keep increasing by 1. So what do you think is going to be the base for the binary number system? 2, right? And that's why it doubles. You have 2 to the 0, which is your 1. Then you have 2 to the 1, which is a 2. Then you have 2 to the 2, which is a 4. Then you have 2 to the 3, which is an 8. And if you forget your math, these are your powers right there. All right? That's how it works. Okay? So the easy way to convert a binary number to a decimal number is basically you put the binary numbers. This is your binary number 10. I mean, the binary number for the decimal number 10. 1, 0, 1, 0, right? So underneath it, you write the 1, the 2, the 4, the 8, you know, they double, 16, 32, however long this thing is. Okay, so I have 4 of them, so it's 1, 2, 4, 8. Then I just multiply the green times this number. So 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. So that's 8 plus 2 plus zeros, and that's a 10. So the binary number 1010 is the decimal number 10. That's how we convert from binary to decimal. Make sense? Any questions?
Yeah, why are those zeros? The 2 square root 2.
This is a 0, this is a 0, so I multiply 0 times 4. 0 times 1. Does that make sense?
I'm just wondering why it's a 0 to begin with.
Why does it begin with 0?
Binary wise.
It just does. just like with the decimal, it starts at 0. That's the system of these numbers.
I mean the green zeros.
Oh, this here?
Yeah.
That's just some number I made up.
Oh.
Yeah, it's just some random binary number I made up. Yeah, 1010, just whatever.
Oh.
Yeah. No good reason whatsoever. I just made it up. Okay. All right. So now that we know how to convert from binary to decimal, there's also a way to convert from decimal to binary. I give you some decimal number. You can convert it from decimal to binary. Okay. How do we do it? Well, it's right here. So let's say we have the decimal number 61, and I'm trying to figure out how to make, what is the binary representation of this number? I get the 61, I divide it by 2, and I get 30.5. Okay, I ignore the 0.5, I get the whole number, the 30, I bring it down. Now it's 30 divided by 2 is 15.0. I ignore everything after the decimal, I bring it down to 15. 15 divided by 2 is 7.5. I ignore the decimal, I bring the 7 down. 7 divided by 2 is 3.5. I bring the 3 down. 3 divided by 2 is 1.5. I ignore the decimal, I bring the 1 down. 1 divided by 2 is 0.5. As soon as I get to 0 something, I stop. Okay? If at any point while you're doing this, you get a decimal that is not a 5 or a 0, you're doing it wrong. So it's only supposed to be a 5 and a 0. Okay, anything else, you did it wrong. Okay, and how would you do it wrong? You probably brought down the whole number. You tried to bring down the 30.5 and you divided that. No, bring down only the whole piece. right? Just whatever's before the decimal. Okay, so once we do this, then we're going to look at my decimals, right? So if my decimal happens to be a 5, then I'm going to say that that's a 1. So this one is a 5 here. That's also going to be a 1, right? Then the next one over, it's a 5. That's also going to be a 1. Then I have another 5, right? That's also going to be a 1. Then I have a 0. If I have a 0, then I'm going to say that's a 0. And then when I see another 5, that's a 1. And then the next and final step is I'm going to read these numbers from the bottom up. That's why I drew this arrow up, right? So the binary number for the decimal 61 is 111101. 11101. Okay? And you can verify it by just going back to the binary conversions, right? Line up the binary, try to put the 1, 2, 4, 8, 16, all that good stuff underneath it, add them up, see if it adds up. That's one way to verify. If you have a calculator on your computer, if you're on a Windows or on a Mac, it has its own calculator, right? And on Windows, you have to go into programmer mode. On the Mac, it's a little bit more weird. Calculator. You have to go view. There's also a programmer mode, right? So both the Windows and the Mac calculators, they have programmer mode. You go in there and you can type these up, right? So let's say I want to go. These are my. Let's say, what do I have? Let's go with 1010. I think I have to click it. There you go. 1010. And if I want to go convert to decimal, hit. Whoops. What's wrong with this thing? No, I think. Let's do it another way. So I want to say 10. Oh, there you go. It's on the bottom. It's on the bottom row right here. All right. So you can click it. 1. So that's a 2, right? So this is a 1. That's a 3. That's a 7. 15, right? So you just click these things. You just type. You press. You can click on this little thing here, and you type calculator. All right, and then when the calculator opens up, then you go to view and then programmer. Okay, and it's similar to the actual Windows one is actually a little bit easier to use. Okay, so this is how we convert back and forward, and you can verify it with the calculator if you feel like it. All right, so I actually have an assignment that goes with this. Open this and have a look at it. All right, so what I ask you in this assignment is convert the following 2 decimal numbers from decimal to binary. I already showed you how to do it. Just show all the work as you're doing this. Don't just type it in the calculator and give me the answer, because you don't get any points for that. And then you do the same thing for the binary. So all you got to do is just use the example that I just showed you. There's a link in there too to the same example. And that's it. So that's that. That's one. And while we're at it, I'm going to tell you about this other assignment that I have in here, which is the hexadecimal conversion business. All right, there's a link in there. Okay, so the hexadecimal numbers are another number system, right? So if our number system goes from 0 to 9, and then after that, every other number is derived by using these other 10 digits before, right? So the 10 is just a 1 and a 0, 11 is a 1 and a 1, then it's a 1 and a 2, etc., etc. Okay, there's another number system called a hexadecimal number system. Okay, and this number system is used in memory addressing, like the memory places, the memory addresses in your RAM, for example, use hexadecimal numbers. Okay, in fact, let me show you. So if I go, let me go to CLion, right? So let's say all the way at the top, I have int a, right? Just some variable I made up. Okay, and if I do cout %a, I'm going to say memory address of a is, and quotes in there, and L. And if I run this thing, look at this piece. Look at this beauty. All right. 07FFF55E5099C. What do you think that is? That's a hexadecimal number. Okay? So there's a whole bunch of memory addresses in your RAM, right? This computer's got 16 gigs of RAM. There's millions of little memory addresses, okay? It will take me a lot more digits to represent these millions of memory addresses with decimal than it would if I did it with hexadecimal. So the hexadecimal is just a way for me to reduce, a whole lot of digits to less, okay? It's also used in like networks. Like if you have an IP address of Google or some place on the internet, up to recently they used binary numbers like 132 dot something something dot something something dot something something. But since we ran out of IPv4 addresses, the IPv4 addresses were the ones that used binary. Now we're starting to use hexadecimal as the IP addresses for network devices, right? So any device on the internet has its own unique identifier, right? If I go online and I do what is my IP, right? That's my IP. That's an IP. That's actually this is a decimal representation of a binary address, okay? So the actual what's 207 and what's the number 207 in binary? You can convert it. But basically, each of these is 8 bits. So this is 8 bits. So that's why the memory addresses can go up to 254. They don't go to 255 because the 0 and the 5 is actually used for something else. So they go from 1 to 254. Okay. Plus, there's some groups of addresses that are reserved for different purposes. Anyway, this here is my IP address, and just to make things fun, how do you? And by the way, this is actually the IP address of, let's see. All right, see, it actually identifies me as California State University, close enough, right? But it knows that I'm in Gilroy, okay? So whenever you're online and you're trying to download something, they can trace you, right? They can figure out who you are, all right? And that's why if you're downloading something from like Pirate Bay or whatever, you might get a letter from your internet service provider telling you, oh, you downloaded I don't know, whatever, Prometheus or whatever movie that you like to download. Okay, so how do you hide your identity? You have no idea. Don't download in the first place, but what if I want to download something? I just don't want them to know.
Isn't there a thing you can block it and like it gives you a different IP address every time?
There is something that gives you a different IP address. It's called a VPN.
Oh.
VPN, right? Virtual private network, right? So let's say I want to go in there. I'm going to say, all right, I'm going to choose my location. Don't ask why I have this, right? I never download things, okay, illegally. So I'm gonna go to. I have all kinds of countries in here. So give me a country. Netherlands, got it. Netherlands. Where do you want? Amsterdam. Let's go to Amsterdam. I'm in Amsterdam now. Hold on. Let me turn this on. Connecting. And actually, the IT people here at Gavilan are really good at these kind of like figuring out how to block this kind of stuff. They haven't figured out how to block the VPN yet. Okay, so now what I'm going to do is I'm going to reload this thing. Hopefully, it tells me I'm in the right place. Yeah, I'm in the Netherlands. Woohoo! And it's a different IP address. So I can go now and download whatever I want. They're going to think somebody from Netherlands downloads stuff. Nobody will ever know.
If you're being tracked, people who track you, I'm guessing they're more higher up. They haven't found any way to beat VPN?
Well, the way the VPN works is the virtual private network, the way it works is I am connecting to a server, but my connection to the server is encrypted using like 256 encryption, like really hardcore encryption. So my traffic between me and the server is encrypted. They don't know what I am downloading between me and the server. They might know that there might be like millions of users at the server and they're downloading a bunch of stuff that they're not supposed to, but they don't know which one I am, right? And they can't really prove it because my traffic between the server and me is encrypted. So it's like a tunnel, right? And there's other ways to hide your identity, but for as far as downloading things, that's the only way to hide yourself. Okay? Just a little FYI. Now you know. Okay? So let me turn this off. Now let me try to reload this page. What is my IP? Oh, I'm back in Gilroy. Okay? Now you know. While we're on the topic of IPv4 and IPv6 and IP addresses and hex and all that good stuff. All right, so let's go back to the hexadecimal business. Now that I showed you the fun things. Okay, and by the way, there's another way to get, like, kind of hide your identity, and that's more for just browsing things, and it's called Tor. Any of you heard of Tor? All right, and you can Google Tor browser.
What would you ever have to download that you're trying to like hide from being traced?
What would I ever want to download? Well, remember, I never download anything illegally. But hypothetically, let's say I go to Pirate Bay and I want to download the latest movie that was in theaters. Right? What happens is you have like Fox, 20th Century Fox, they have people that are actually seeding the movie. So if what they're doing is they're having somebody in there giving you the movie, and then they're telling you, hold on, this guy downloaded it from me. Here's his IP address, and then they're going to report you to your internet service provider, and then your internet service provider is going to tell you, we just found that you downloaded this movie illegally, and blah blah blah, and then they're going to send you like a couple of nasty notes. I think they're supposed to send you like 6 of them, and then I don't think they do anything after that. They're just supposed to send you like six scary notes to scare you from stopping. But if you don't ever want to have a scary note from them, VPN. Also, never ever 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 download from this school's network anything illegally, because then they're really gonna get you, because it's not gonna be just a note from your internet service provider. That person who's been seeding the information is going to contact the college. Is going to tell them, look, you guys are doing something illegally, and then it's the college's job to go to you and tell you, hey, we know you did this. We have this record. This was your IP address. You downloaded Prometheus or whatever illegally, and then you're going to have to go and fill up like a form, and make up some reason why you didn't do it or whatever. You were at your friend's computer, and you were trying to use the library or some excuse, and then sign a letter that you will never ever do that again. Of course, that never happened to me, right? I just kind of know about this stuff. All right. So anyway, going back to hexadecimal number systems. The hexadecimal number systems you saw them like memory addresses. They're also used in the internet for addressing devices. Is numbers, it basically goes from 0 to 9, just like our decimals, but then instead of a 10 through 15, you have A, B, C, D, E, F, right? So you use a couple of letters to do this kind of stuff. Okay? Question?
Does it just go to F, or is that where you just stop?
It's just F, yeah.
Okay.
So it's hexadecimal because there's 16, right? There's 9, 10, 11, 12, 13, 14, 15, yeah. Yeah, 16, there's 16 of them, so that's why it's hex, right? Hexagon is a shape with 6 sides. Octagon is a shape with 8 sides, right? So, let's say I want to convert the number 1E5DF into decimal, right? So this is my hexadecimal number. I'm trying to convert it into decimal. I go like this. So I grab the F, I bring it down, right? 15 times 16 to the power of 0. Why is the base 16? Because it's 16 digits plus some letters, right? And then the next one is a D. What is the letter D? The D is 13, right? I go in reverse order. I go right to left, right? So 13 times 16 to the power of 1. Then the next one is a 5. 5 times 16 to the power of 2. Then the next one is the E. What is the E in decimal? It's 14. 14 times 16 to the power of 3. Then the last one is the 1. 1 times 16 to the power of 4, right? And then you will multiply all these, you add them up, and there you go. 124,383 is the decimal representation of 1E5DF. Then you can see that, you know, the number in hexadecimal is a little bit shorter, so you use a little bit of less space to represent big numbers, and that's why really why we use these. Okay, so what you have to do, and I have another example underneath that if you want to look at it, in case the first one didn't make sense. Is there any questions on this? Pretty straightforward. Okay, so your mission, should you choose to accept it, is convert these numbers in from hexadecimal to decimal using show all the work that as I have shown you here. So that's that. So that's converting from hexadecimal to decimal, and I also have to show you how to convert from decimal to hexadecimal. So let's say we're trying to convert the number 300 into hexadecimal. I get the 300 divided by 16. Why is it 16? Because we got 16, right? 16 numbers and letters. So 300 divided by 16 is actually not 18, it's 18 point something. But we ignore the point something just like what we did with the binary. Then you do 18 times 16, right? 18 times 16 is 288. Then you subtract the 288 from 300, and that's your 12. What is a 12? 12 is a C, so that will be a C, right? Then I get the 18, I bring it down. 18 divided by 16 is 1 point something, and we ignore the point something, right? Then I do 1 times 16, which is 16. Then I subtract the 16 from the 18. That is a 2. 2 and hex is just a 2 in decimal. Okay, then I get the 1. 1 divided by 16 is 0 point something. 0 times 16 is 0, right? I subtract the 0 from the 1, and that gives me a 1, and then I'm done, right? I stop when I get a 0. Okay, and then just like with the binary, I read these things from the bottom up. So 300 in decimal is equal to 1, 2, C. Got it? All right, so that's how we do it. And then I have another example underneath just in case that first one didn't make sense, just so you have another one. And your mission for this one is convert from decimal to hexadecimal. Make sure you show all your work. Okay, and then so this is 8 of them so far. And then after that, use the Windows or the Mac calculator. If you're on Linux, good luck to you. Find a freaking calculator on Linux, and use the calculator to convert these numbers from hex to binary, and then also use the calculator to convert this big binary number and actually these 4 big binary numbers into hexadecimal. Okay, and actually the conversion of these are not too bad, right? So for example, this here, what is this number in decimal? 2, right? What is 2 in hexadecimal? 2. So that will be a 2. So the way you convert them is you convert each of these to decimal, then you convert the decimal to hex. So this will be the 2 in hex, then you convert the next one to decimal, convert that. So this is basically going to be 4 possible numbers or letters in hex.
And then back and forth again.
Well, you can just do it with the calculator, right? You don't have to do it in show the work or whatever. But if you want to, same thing, right? So what would be this? How would I convert this in hexadecimal? Well, in binary, I would grab each of these individual things and I would convert them into binary, right? So what is 8 in binary? 1, 0, 0, 0, right? So the last 4 digits are going to be 1, 0, 0, 0. What is the B in binary? Something, well, something else, right? Convert that. But you don't have to. You just you don't have to show the work. Just it's a practice using the calculator. So click away if you're on a Mac, and have an easier time if you're on Windows. So these are the 2 assignments that you have to do as far as number conversions are concerned. And I already showed you how to do the random number business. Think of the algorithm, right? I have like that little note in there. Remember what an algorithm is?
I mean, I know the word, but like it helped probably.
It's a recipe, okay? What is a recipe? It's a step-by-step instructions that you need to follow to solve a problem or cook a meal, okay?
That's what I was gonna say.
That's what you were going to say. All right, good. What else? What else? So let me quit this thing. Let me go back to my C lion. So I showed you the random number businesses. I showed you the conditions. I guess let me finish up the little review that I had going. All right. What else I had in there? All right. So what else? So how do we make the program decide between different things? Well, you tell it using ifs and elses or else ifs, right? So basically, let's say you have some kind of a variable age is equal to 1,000. If the age is less than 0, you show this message, and otherwise, else, you show this message, okay? The else automatically happens when the previous if is false, right? This is your condition. If the condition is true, we show this message, okay? And remember, if you have a single line underneath the thing, you do not need to use curly brackets. You could use curly brackets if you really want to. You can throw some curly brackets like this, right? That won't hurt, okay? And then underneath it, this is just a review from last time, right? You can have also an if, else if, right? Remember the little example that I gave you with the oldest lady in the world, right? If age is less than 0, that's a bad age. If the age is over 123, that's also a bad age because nobody lived that long as far as we know, okay? All right, unless you believe fairy tales. All right, then we go to the next one. The ors, right? So if I have this stuff here, okay, if you have an if, well, yeah, if one thing, show a message, and then another thing, show another message. So the else if, remember that else if happens or gets, so the condition of an else if gets checked when the previous thing is false, okay? So only if this thing is false are we going to go and check this here, okay? And if I want to, I can reduce these two lines of code to this here, right? Whoops, wrong one. All right. Basically, I can use an OR. Okay. What is an OR? It's a logical operator which allows you to combine a couple of conditions. So you have a condition 1, you have a condition 2, and the possible arrangements of these are like this. So you can either have a true, true, false, true, true, false, false, true, false, false. This thing evaluates to true if both or one of these things is true. Only if both of them are false does this thing not show. Okay, so this thing is true if one or both of them are true, and it's false if only both of them are false. Okay. Another thing is, so in here I have some if-else chain, right? So, and what's the purpose of the if-else-if chain? It's basically stop it at the first thing that's true. If you have a whole bunch of things, if you have an invalid age, right? If you have an invalid age, don't bother going and checking anything else. If you don't have that, you could get some unexpected results, like we saw. You have an invalid age, but then you have some if age is less than 18 in there, so that message is going to show up. Okay? And this here, it was the illustration that I had that if you have multiple statements or multiple lines of code, you need to have the curly brackets. Okay? If you have a single line of code or a single statement, you can get rid of the curly brackets. So this will work just fine. Okay? So that's that.
So else
Yeah.
is supposed to be like the last one where it's like
That's an else.
Oh, that's just else.
Else, right? Yeah. So and that brings me to a let me just I guess I'll do it right here. So let's do this. Let me go to C line. Okay, so let's say I have this situation. I have do I have an age in there? No, age. All right, so let's do this. I'm going to have an int age is equal to 1. And then in here I'm going to have if age is equal to 1, cout age is equal to 1, and del I'm going to copy this thing. Why don't you like it? Condition is, okay, thanks for telling me. Then the next one, if age is equal to 2, and then else, I'm going to have, what the hell? Condition is, oh, it's false. Okay, good. And then in here, I'm going to have a cout, hello world. Okay, so my question to you is, kind of to illustrate the one type of confusion that comes up every so often. All right, so my question to you is, when would this message show up? When would the hello world show up? For what value? For what value of age will this show? So if I have it just like this, right? If I have my program like this, is it going to show? No? All right. I'm not sure. Let's see. Oh, what? Hello. It shows. How come it shows? Because if this is false, this will automatically show. Right? Is age equal to 2? Nope. So this is going to show. So how am I, so, right? So
It doesn't matter how many are true, it's just once one's wrong, then it skips else.
well, the else automatically, remember, else automatically happens when the previous if or else if is false. Okay? So basically this, so for what value of age will this show? What if I have an age 2? Is it going to show then? Is this true? Yes. So if this is true, then this is not going to show. So the answer is any value other than 2.
But then the first is wrong.
Yeah, the first if is wrong. It's not 2, so that's not going to show. All right. Let me run it again. All right. Age is equal to 1. Oops. I changed this to 2. Forgot. Run it again. All right. Age is equal to 2. Okay. So how am I going to prevent this thing from showing? I just go and I do else if. Okay. So remember that if I have an if else if chain, this thing stops at the first thing that's true. Okay. Make sense? So that's a source of confusion, just so you know. Okay, else if. It's just a matter of practice and thinking about it a little bit. Okay. All right. Let's see what else. So I showed you the and, right? So and is another way for me to show basically this nested if. So you can have an if or an else if, and then inside it you can have another one. And that can be rewritten using an and, the ampersand, right? 2 ampersands. And basically you have one condition and another condition, and both of these conditions have to be true in order for whatever's inside of it to show up. Okay, so this whole thing with the and is only true when both of these are true. Okay, what is the practical application? Well, other than writing programs that logically make sense, like, okay, I'm going to grab the door handle and I'm going to twist it and push it, and maybe if it's not locked, I'm going to open it, right? You can also check to see if a number falls within the range of numbers. Like we're trying to check to see if an age is between 19 and 21, we're going to use an and. And then what's the practical application of the or? Well, you're trying to check to see if a number is outside of an acceptable range, right? We're trying to see if the age is less than 0, if it's outside of the acceptable range of values, such as between 0 and 123. Okay, so that's that. The next thing that I want to tell you about is I'm going to give you some hints on the assignments this week, if you don't mind terribly. Okay? So the first one is P14, right? And for P14, I'm asking you to write a program that generates a random number between 10 to 25. You already saw how to make a random number. You got that down. And you have to tell me if the number is odd or even. Okay? How do we know if a number is odd or even? Well, here's your hint. If a number modulus 2 equals 0, then it's even. Remember when we do the modulus thing? If we do modulus 2, what are the possible numbers that we're going to get? 0 and 1, right? If something is even, any number that is even, modulus 2 will come out to be 0. Any number that isn't, it will come out to be 1. That's it. That's your test for odd even. Okay? Do you want more hints for this? Here, I have it in there somewhere. So this is number 14. All right, here's your hint. I'm going to paste it in C Lion. C Lion. Okay, so I'm going to take, I'll leave that here. There. Right? So you ask the user to, so this is this actually is a random number. Okay? So you make a random number, and if that random number modulus 2 is equal to 0, that's an even one. Else, it's odd. You can also say else if num modulus 2 is equal to 1, right? That will also be odd. You can also say if num modulus 2 is not equal to 0, that will also be odd. And so you can see that there's many different ways that you can write things that make sense, right? So there's no unique solution to any of these programming assignments that I give you. You know, different people are going to write it different ways, right? The better you get at writing the code, usually the more efficient and more elegant and shorter it's going to be, right? So to me, it makes sense to just have it else, right? So if it's not even, it's got to be odd. It's one or the other, right? Just like if it's not negative, it's got to be positive, that kind of stuff. Okay, so that's your hint for 14. You already know how to make random numbers. Okay, next one is 15. And I guess that's a little something new that I got to tell you about. The ASCII table. Okay, so first of all, the assignment is write a C++ program which declares a char variable, letter or number, and ask the user to input any character from the keyboard into that variable, and then tell the user if it's an uppercase, lowercase, so it could be either upper or lowercase, it could be a number, or it could be something else. How are you going to figure that stuff out? You use the ASCII table that I have underneath, right? And the ASCII table, if it ever opens, right? Here's the ASCII table. Okay, what is the ASCII table? Well, every key on your keyboard, every symbol, like the exclamation, right? The exclamation is number 33. Letter lowercase a is number 97. Okay, uppercase a is 65. So the letters from uppercase letters are from 65 down to 90. Okay, lowercase letters are from 97 to 122. Okay, so it's basically you're going to be checking ranges of values. Okay, let me go back to the little hint that I had. All right, so here's a 15 hint. I'm not going to type it because we're running kind of a little bit out of time. All right, so this is your P15 hint. All right, so you declare a character or char variable, call it letter or number. Right, the user enters this information, but let's say, for example, the user enters A, right? Any character is in single quotes, okay? And what I'm going to do here is I'm going to show you the the variable L, right? So if I run this thing here, notice that it shows me letter A, right? That's this line right here, right? And then underneath it, I'm saying cout int L, and then it's going to show me the ASCII representation of that. Okay? So how are you going to figure out if this is an uppercase letter? Well, remember the ASCII chart? If int L is bigger than or equal to 65 and int L is less than or equal to 90, this is an uppercase letter. Okay, what do you have to do? You got to do also an else if for lowercase. So look at your ASCII table, look at the ranges, do that. Do another one, else if, for the numbers. If you forget the numbers, look at your ASCII table. All right, save it again. ASCII table. All right, where are my numbers? Look at the numbers. The numbers are from 48 to 57. So similarly, if something is, if it's a number, it's going to be between those ranges of values. And then finally, else, you're just going to tell them, okay, you entered something else. Got it? Questions? We're good? All right, so that's your hint for the 15. Next one is 16, rock, paper, scissors. All right, so you know the rules of the game, and I pasted a picture in there of the hint that I have. So let me zoom in on this thing. All right, so you write a program that simulates rock, paper, scissors game. Each player either enters RPS or 1, 2, 3 for rock, paper, scissors, and then the program checks to see who wins, right? The rules are paper covers rock, rock breaks scissors, scissors cuts paper, or you can tie if they're both the same. Okay, so how are we going to do this? Well, look at this thing a little here. So what we can do is we can have two variables. We're going to go with numbers. The user is going to be entering numbers like 1, 2, 3, right? 1 is rock, 2 is paper, 3 is scissors. And then, going too fast, then just for convenience sake, I'm going to make 3 variables. Rock is going to be equal to 1, paper is going to be equal to 2, scissors is equal to 3. Then I have to have 3 ways for player 1 to win. So the first way is if player 1 is equal to rock, player 2 has to be equal to scissors, right? So if player 1 is equal to rock and player 2 is equal to scissors, P1 wins, rock breaks scissors. The second way for player 1 to win is, let's say we're going to go with paper. Player 1 is equal to paper and player 2 is equal to rock. So player 1 wins, paper covers rock. You need to write one more if to see if player 1 wins. So what's left? You have rock, you have paper. So now you got to go with scissors. So if player 1 is scissors and player 2 is what? Paper, then player 1 wins. Similarly, you're going to have 3 ways for player 2 to win. And then you're also going to have 3 ways, or if you can think of it, only 1 way for player 1 to tie with player 2. They're just basically equal. If they're equal, it's a tie. Okay, so that's that. Any questions? Okay, let me see if I have it in Sublime in there somewhere. Yeah, I'll paste it in there too. All right, here's your little hint. Paste this in there. So that's your P16 hint. And I think, oh, and I have the Astrology program, which is the last one. Last but most fun. Wait, that's not the Astrology one. P16. I think my numbers are off. Hold on. Week. Rock, paper, scissors, coin conversion. Oh yeah, I have coin conversion also. I'm almost done. All right, so the coin conversion business, I actually give you the hint as a picture in here. So it's going to go like this. You're going to ask the user to enter a total number of cents under 100, and you're going to break it down into like, okay, 66 cents is 2 quarters, 1 dime, 1 nickel, 1 cent, right? How are you going to do it? You ask the user, you have a picture of this thing underneath it, right? Please enter the number of coins, that's the total coins. How do you figure out the quarters? Quarters is total coins divided by 25. If you happen to have any quarters, show the user how many quarters they have, and then subtract the number of quarters from your total coins, and then repeat this thing for dimes, for nickels, for pennies. Okay, last one, the Astrology program. All right, and I have a hint for that too. It basically goes like this. You have all these different zodiac signs. So you're going to ask the user to enter their birthday. All right, the user enters their birthday, and then based on their birthday, you figure out their zodiac sign. All right, I have it as this here. Right, so month is 3, day is 22. Of course, the user has to enter this information. And then in there, you go and you figure out with an if and an or, what's what, right? So let's say, for example, this first one is Aries was between March 21st to April 19th. So any month, so if you have a month equal to 3 and your day is bigger than 21 and your day is less than 31, because that's how many days there are in March, right? Then you happen to be Aries. Or the other way is if you have a birthday which is less than April 19th, so that means your month is equal to 4, your day is bigger than 1 or equal to 1, because that's the first day of April, and your day is less than or equal to 19, then you also happen to be Aries, and then that's it. Okay, so that's one. You got to do all the other 12, or all the other 11. Got it? If you don't, send me questions, send me emails, come see me in my office hours. And also, just so you know, if you Google Gavilan STEM Center, right? There is a STEM Center where there's going to be a tutor, right? From 8:30 to 5 p.m. There should be somebody who can help you there. And I also have a tutor. Marisol is going to be available at these hours, right? And I'm going to post them. I'm going to put them on the class webpage. So Monday, Tuesday, Thursday, Friday by appointment, you can come see Marisol. She's going to be in the tutoring center. She took my class. She did well, so she can help you. Okay? She's already done this one semester, so she knows my assignments. She knows what I want. Okay? So come see me first. If you can't find me, and you don't want to send me an email, go see Marisol or go to the STEM Center. Okay? So that's all I have for today. I'm going to post this stuff at the class webpage, and I'm going to go do my office hours now if you want to come see me.